So, hello. The topic for this module is the logic gate. Nagkaroon na tayo ng background din sa mga logic gates. And ang assignment ng dito ko ang types ng logic gates. So, our learning objectives here, syempre, is to identify and explain the functions of the basic logic gates. Mag-draw nyo yung symbols for the basic logic gates and develop truth table for the basic logic gates. So, alam naman natin for the all digital equipment, whether simple or complex, is constructed of only a few basic circuits. These circuits refer to the logic elements. This performs some logic functions on binary data, and there are two basic types of logic circuits, decision making and memory. So, sa decision making, mga logic circuits monitors binary inputs and produce an output based on the status of the inputs and the characteristics of logic circuits. And then when it comes to memory circuits are used to store binary data. So, ito na. So, our first logic gate is the AND gate or the AND gate. So, sa AND gate, sinasabi is the AND gate is a logic circuit that has two or more inputs and a single output. So, sa AND gate produces an output of 1 only when all inputs are 1. So, if any of the inputs are 0, the output is 0. That's why in this figure shows the standard symbol used for AND gate. An AND gate can have any number of inputs greater than 1, and the figure are symbols representing the more commonly used gates of 2, 3, 4, and 8 inputs. So as you can see there, let's say you have an input A and B, and then your output will be AB. And when your input is A to D, your output is ABCD. And then when your input is A to H, then your output will be ABCDEFGH. Okay, paano nga ba natin malalaman? Sinasabi nila, pag merong kang input na 1, both inputs ay dapat yung output mo ay 1. So, the operation of the AND gate is summarized by the table and tinatawag itong truth table. So, ito yung pinapakita dito yung mga output for each possible input. So, the inputs are designated A and B, and the output is designated Y. So, the total number of possible combination in the truth table is determined by the following formula. In where N is the total number of possible combination, and the N is the total number of input variables. That's why if you have two input variables, which is an A and B, M equals to 2 raised to 2 is equals to 4. Kaya kung mapapansin nyo, sa A and B, meron kang 4 inputs. Yun yung mga possible inputs. And then, example na din, for 8 inputs, N is equals to 2 raised to 8. And then, it equals to 256. So, kung titignan nyo dito, yan sa part na yan, magiging output mo dito ay 4. Ito. And then, syempre, pag 8, ang magiging output mo dito ay 256. Sunod-sunod yan. So, kung makikita mo dito, ayan, sinabi nga natin, pag sa AND gate, pag ay input mo ay lahat ay 1, yung output mo ay 1. Pero pag 1 sa input mo ay may 0, yung output mo ay magiging 0. Kaya in example is input A and input B ay 0, and then your output is 0. And then input A mo is 1, and then 0, 0 pa din, vice versa, 0, 1, 0, and then both inputs ay merong 1, ay merong kang output na 1. So, the AND gate performs the basic operation of multiplication. So, the output of an AND gate is represented by equation y equals A times B or YAB. And the function is represented by the dot between the two variables A and B. Now, sa OR gate, okay? When it comes to OR gate, an OR gate produces an 1 output if any of inputs are 1. So the outputs of 0, all inputs, the output is 0 if all the inputs are 0. Kaya kung mapapansin nyo dito sa may truth table ng OR gate, yung input A and B mo ay 0, 0, then your output will be 0. So the output of two input OR gate is shown in the truth table. So the total number of possible combination is expressed by n equals to 2 raised to 4 equals to 4. So the truth table shows all 4 combinations. Yeah, piliin natin. Okay, para maintindihan ng lahat, pag meron kang isang input na 1, okay, as long as meron kang 1, your output will be 1. So an OR gate performs the basic operations of addition. The algebraic expression for the output of an OR gate is a system y equals a plus b. So the plus sign designated the OR function. Kaya kung mapapansin nyo dito sa figure, shows the logic symbol of OR gate. The inputs are labeled A and B and the output labels 1. So they can have any numbers of input greater than 1. Makikita nyo sa mga 2, 3, 4, and 8 inputs. Kaya kung makikita nyo dito, okay, A, B equals to Y equals A and A plus B. Simpleng-simple. Okay, so example lang natin. Yan. Kahit magkaroon ka ng 1 dito. Okay, so A and B, 1, 0, Y is equals to 1. Okay, and pag dito naman, nagkaroon ka ng example, 1, 0, 1, 0. Okay, so A, B, C, D. So, hindi magiging equals to 2 yan ah. Hindi yan 2. Yung Y equals to 1. Ganyan ang mangyayari sa OR gate. Next, sa NOT gate. Okay, so when it comes to NOT gate, the simplest logic circuit is the NOT gate. It performs the function called inversion or completion and is commonly referred to as an inverter. So the purpose of in the inverter is to make the output state opposite of the input state. So the two states associated logic circuits are 1 and 0. So the one state can also referred as to high to indicate that the voltage is higher than 0. And the 0 state can also referred as low to indicate the voltage is lower than 1. So if a 1 or high is applied to the input of an inverter, a low or 0 appears on its output. If the 0 or low is applied to the input, a 1 or high appears on the output. So in the truth table, simply sa NOT gate, the operation of an inverter. So the bar over a letter indicates complement of A. Kaya minsan pwede nyo makita dyan is, sorry. Okay, pwede nyo makita ay A na may bar sa ibabaw. So, pinaka-example, if nag-input ka ng 0, kabaliktaran lang. Hindi 1. And then, pag nag-input ka ng 1, magiging output mo ay 0. So, the symbol used to represent an inverter or not function is shown dito sa may figure. Ayan. Simply, ganito itsura ng inverter. So, the triangle portion of the symbol represents the circuit, and the circle or the bubble represents circuit inversion or complementary characteristic. So, the choice of the symbol depends on where the inverter is used. So, if the inverter uses a 1 as a qualifying input, the symbol in 36A is used. So, if the inverter uses 0 and the qualifying input symbol is makikita nyo dito sa may 36B. Okay. Kaya kahit walang value to, okay, okay. So, kahit walang value yan, basta magigets nyo to. So, siya ay isang 1 na. And then, gawin din dito, pag ganito yung bubble niya or yung circle, it's indicate as 0. So, kahit wala siyang value, ma-indicate mo na yung input niya ay 1 or 0. Pero ang kalalabasan niya, example niya, input niya ay 1, ang output niya ay 0. Let's go to the NAND gate. So the NAND gate is a combination of an inverter and an AND gate. It's called a NAND gate. So gate from the NOT AND function it performs. So the NAND gate is most commonly used logic function. This is because it can be used to construct an AND gate or gate, inverter, or any combination of these functions. So simply, kahit hindi na ganito ang makita niyo sa figure, simply, ayan yung makikita niyo sa figure, concave siya and meron siyang circle sa ibabaw. So sa symbol na yan, also shown is its equivalency to an AND gate and an inverter. So the bubble on the output end of the symbol means invert the AND gate function. Para mas maintindihan natin kung ano yung kakalabasan niya. So, sa truth table, okay? So, for the two input NAND gate, notice that the output of NAND gate is the complement of output of the AND gate. Any 0 in the input yields a 1 output. Okay? So, ulitin natin. Pag nakakita ka naman ng 0 sa NAND gate, ang ibig sabihin lang, meron siyang output na 1. Kaya kung mapapansin nyo sa inputs A and inputs B, para siyang merong input na 0 or sabihin natin low, yung output niya ay high. And then input niya ay 1 and input niya sa B ay 0, meron siyang output na 1. But if both inputs are high or there's an input of 1, then the output is 0. So the algebraic formula for the NAND gate output is y equals to bar AB, where the Y is the output and the A and B are the inputs. So NAND gates are available with 2, 3, 4, 8, and 13 inputs. So si NAND gate are the most widely available gates on the market, and the availability and flexibility of the NAND gate allows it to use for the types of gates. Kaya kung titignan nyo dito sa may table na to, yeah, I think using NAND gate to generate the logic function. Yeah, example sa inverter, logic symbol. And guys, so here sa figure to, pinapakita lang na si NAND gate I can generate other logic functions. Okay. So katulad ng inverter, AND gate, and OR gate. Yeah. So next, we're going to NOR gate. Okay, so sa NOR gate is a combination of an inverter and an OR gate. Its name derives from its NOT OR functions like NAND gate. So the NOR gate can also be used to construct an AND gate or OR gate and an inverter. So the equivalency to an OR gate and an inverter, the bubble on the output of the symbol means to invert the OR gate. Yeah. So as you can see here, so input A and input B is Y is equals to bar A plus B. So simply, on the truth table for two inputs NOR gate, notice that the output is complement of the OR function. So A1 occurs only when 0 is applied to both inputs. A1 input produces a 0 output. Okay, so the algebraic expression for the NOR gate output is Y equals to A bar A plus B. So as you can see dito sa may figure, sa NOR gate na may two inputs, okay, the input A and B is when 0 and the input 0 and 0 is equals to 1, and the input 1 is at A and the input 0 at B is equals to 0. So, lumalabas dito pag meron ka daw input na 1 or high, magpuproduce siya ng output na 0. So, only yung output mo ay 1 pag 0 yung applied mo sa both inputs. So, ganun yung nangyari kay NOR gate. So now we have the exclusive OR gates and NOR gates. So a less common but still important gate is called an exclusive OR gate, or abbreviated as XOR. XOR. An XOR gate was only two inputs, unlike the OR gate, which may have several inputs. However, the XOR is similar to the OR gate in that it generates a one output. So if either input is 1, so the exclusive OR gate is different when both inputs are 1s or 0s. In that case, the output is 0. So here, the symbol of XOR gate is shown in the figure. Also shown the equivalent logic circuits shows in the truth table for an exclusive OR gate. So the algebraic output is written as Y equals A exclusive or B. Yeah. So as you can see, when you have an input A 0 and input B ay 0, your output is 0. When your input is 1, and then your input is 0, then your output is 1. When the input is 0 and the input is 1, output is 1. But both inputs are 1, you will have a 0. Okay, so mag-add din tayo pag sa exclusive OR gate. So sinasabi, sa exclusive OR gate, sila ay A or B but not both gives the Y. So, dyan, yung napakita dito is yung 2 inputs lang. So, what if meron kang 3 inputs na XOR gate? Okay? 3 inputs ng XOR gate. A, B, C. So, simply, lahat ng any odd numbers, okay, any odd number of input gives the Y an output or nagkakaroon ng 1. Kaya dito, kung mapapansin nyo din dito, okay, kung mapapansin nyo, 0, 0 equals to 0. So 1 is to 0 is equals to 1. So add number kasi 1. So what if nagkaroon ng pangatlo? Okay. Example ay 0, 1, 1. Nagdagdag ka dito ng isa pang input na C. Letter C yan ah. A, B, C. So equals niyan ay 0. Example. So the symbol used to denote an exclusive or odd function is slightly different to that for the standard inclusive OR gate. So the logic or Boolean expression given for the logic OR gate is that the logical addition, which is denoted by the standard plus sign. So lahat ng exclusive OR gates are used mainly to build circuits that perform arithmetic operations and calculations, especially others and half others, as they can provide a carry bit function or as a controller inverter, where one input passes the binary data and the other input is supplied with the control data. So what if naman dito sa meron tayong exclusive NOR gate? Ayan. So the complement of XOR or XOR gate is the XNOR or the exclusive NOR gate. So its symbol is shown in the figure. Ayan. Kung mapapansin niya, balik tayo, balik. Yeah. Okay, wala siyang bilog dito. Pero pagdating dito, meron na siyang bubble or circle dito sa may dulo na part. Yan. So, the bubble on the output implies inversion or the complement, also known as the equivalent circuit. So, the figure na shows the truth table of the exclusive NOR gate. The algebraic output is when the Y is equals A exclusive NOR B. Yan. So, kung makikita nyo naman, pag input niya ay both 0, ang output niya ay 1, And then pag input niya ay 1 sa A, ang input niya ay 0 sa B, 0, and vice versa. And then pag both inputs ay 1, output niya ay 1. So, ang kinakalabasan niyan, read if A and B is the same. Okay? Pag A and B is the same. Kaya dito, A, B, same sila 0, output ay 1. Then A, B, same sila ng 1, output niya ay 1. So, sa exclusive NOR gate, katulad, ni-read siya any even numbers of the input. Katulad no, kabaliktaran naman to exclusive OR gate. Okay. So, kanina, karoon tayo ng example. Pag nagkaroon ng 3 inputs, 0, 1, 1, ang output. Exclusive OR gate ay 0. Dito naman, pag may input ka na 0, 1, 1, ang output ay 1. So, lahat naman ng even numbers, so ibig sabihin, isa lang, syempre, 0. Pero pag nagkaroon na siya dito ng 3, magiging 1 na siya. Ano nangyayari? So, we said previously that XNOR function is a combination of different basic logic gates, XOR, and a NOT gate. And by using two inputs truth table, we can expand XNOR function to y equals A exclusive NOR B, which means we can realize the new expression using the following individual gates. And then simply, we have a buffer. So a buffer is a special logic gate that isolates conventional gate from other circuitry and provides high driving current for heavy circuit loads or panel. So buffers provides non-inverting input and output. So A1 or high and provides a 1 out, and a 0 and provides a 0 out. So simply dumaan lang yung circuit mo or yung pinaka-circuitry. Okay, pero may symbol pa din. Kaya dyan, sa schematic symbol for basic buffer fit its truth table. Pag output mo ay 0, output mo ay 0. Pag input mo ay 1, and output mo pa rin ay 1. So, ulitin natin. Ha? So, sa digital buffer is the logic gate opposite of an inverter. The NOT gate, we look at its previous symbol. Okay, NOT gate's output state is the complement, opposite, or inverse of its input. So, Y is true only when the A is true. Simply. So, lastly, meron tayong tri-state or three-state buffer. Okay, so the three-state buffer has usually 1 and 0 output states, but it also has a third state, which is referred to as a high impedance state. So this provides an open circuit between the input circuitry and the output is controlled by the EN line. So the EN line or end line represents an enable or disable control input. So figure on the next page shows the stage buffer of the rates. this one. So as you can see here, okay, standard logic operation if input mo ay 0, okay, and then output yung end line mo ay 0, output mo ay 0 or 1. Pag 0 or 1, yung input mo and then yung end line mo is 1, then there will be no output. Yun natin. Okay. 0, 1. Pag yung end line mo ay 0, either 1 or 0 pa din. But if yung end mo ay nagkaroon ng 1, pag nagkaroon ka ng input ng 0 or 1, the output mo ay 0. Okay? So, to summarize all the topics we've discussed, an AND gate produces a 1 output when all of its inputs are 1s. An AND gate performs the basic operation of multiplication. An OR gate produces 1 output if any of its inputs are 1s. An OR gate performs the basic operation of addition. A NOT gate performs the function called inversion or complementation. The NOT gate converts the input state to an opposite output state. The NAND gate is a combination of an AND gate and an inverter. And a NAND gate produces one output when any of its inputs are zeros. So a NOR gate is a combination of an OR gate and an inverter. And a NOR gate produces one output only when both inputs are zeros. So an exclusive OR or XOR gate produces one output only if the inputs are different. An exclusive NOR gate or XNOR gate produces one output only when both inputs are the same. A buffer isolates conventional gates from other circuitry. A buffer provides high current for heavy loads or fanouts. So a tri-state buffer has a high impedance third state. So I'm hoping meron kayo na-gets dito sa topic. Lalo na just to identify the symbols of the different logic gates and the truth table. And then after that, you have to answer the following questions provided in the slides. So you can see all the questions in this module. Thanks, guys.